And 1.2 plus 0.49 is what?
1.69.
1.69. Okay, well, you should recognize that if you just look at 169 without the decimal points, that's a perfect square, isn't it? It's 13 squared. All right, well, it's still a perfect square even though we put decimal points in it. When I take the square root of both sides, just put it here, and I need your assignment number 11. Where do you think the decimal point goes? If you're going to multiply 13 and 13 and get 2 points afterwards. 1.3. 169, the square root is 13, right? If you're going to multiply 13 and 13 and your answer has a decimal point with 2 spaces after it, what's the rule for multiplying with decimals? However many decimals are in the problem, that's how many decimal spaces you have in your answer, correct? Well, since we're multiplying the same number, the decimals have to be there. Subtract 0.7 from both sides, and then do the math. Think of it as not even having decimals. Negative 7 plus 13. What's negative 7 plus 13? Negative 7 plus 13 would be 6. There's a decimal point here. What's negative 7 minus 13? Negative 20, but there's a decimal point in there, right? You don't have to put 0.0. Blake Gotro, do you have assignment number 11? Why? Just remaining consistent? Okay. Number 46. Okay, that's not factorable. So I need to set it up. This is already a coefficient of 1, so I'm good. All right, so I'm going to take 26/9 and put it on the other side. And then I'm going to figure out what goes in parentheses. And Lamar is going to tell me what goes in parentheses. Two-sixths. Okay, Annalise, I take it back. At this point, we can reduce 2/6 to 1/3. Okay? Because it's going to make our fractions easier. Because this is 2/6, I can go ahead and reduce that to 1/3. So my numbers aren't so big. Okay? And I'm going to have a common denominator already.
Wait,
Because, no.
So normally we don't reduce it whenever we put it in there?
It's not that I said don't reduce. It's don't change it to mixed numbers. Okay? Don't work with mixed numbers. And if you see that the fraction without reducing is going to work out where you have a common denominator already, then don't reduce. But that takes foresight. It just takes practice and it takes working a lot of problems. Okay? There's hardly ever in math a definite always do this way. You've got to see what you're working with. Here, when we square 1/3, we're going to have 1/9, and we already have a common denominator. Huh? Yes, you can change that to 3. Because 27/9 is 3. And now we're going to take the square root of both sides, which gives us x minus 1/3 is equal to plus or minus the square root of 3. 26 plus 1 is 27 over 9. And 27/9 is 3. Right? And then I took the square root of both sides. Adding 1/3 to both sides. Why are they both not over 3 this time?
Because it's the square root.
Because this was not a fraction. That was a whole number. Okay? I only put them both over a 3 if they are both over a 3. But the first one was only the square root of 3.
So if you had 9 plus the square root of 27 over 3, it wouldn't have been reduced all the way.
You can reduce the square root of 27. Square root of 27 is 3 times the square root of 3. This is this, okay? I would accept this answer, but because of how we solved it, it was separated. The way you would separate it and reduce it and get back to what you just had is recognize that these are both a third. And now this fraction individually, the 3's cancel out. So you have 1/3 plus or minus the square root of 3. Okay? But this is not simplified because the square root of 27 can keep going. You can pull a 3 out of there. Okay? Nick, you had a question?
You don't have, like, when you reduce, I think it was like 3 over 27 or something. Or you made it 3. Do you have to do that?
No, you don't have to. You can keep going and you'll still get the same answer. Okay, now let's do this one. The picture frame question. All right, you have a picture frame. Okay, we'll just work with that for now. All right, you have a picture frame and they said it's square. What do you call the dimensions of a square? Side and side. They're all equal, right? Okay. All right, we're going to be looking with area. So when you're finding the area of a square, what is that?
S squared.
S squared, correct? Okay, so we know that the picture itself has dimensions of S and S. Now they tell us that the frame is an additional 2 inches, okay? So if we're going to look for the dimensions here, it's the distance from this point to this point, which is what? S, plus 2 more inches here and 2 more inches here. So what would the total length be?
S plus 2.
Just S plus 4. All right? Now, since it's a square, wouldn't the dimensions the other way be exactly the same? Yes. Okay, so from here to here is S plus 4. So what we have are the dimensions of the picture itself, and then we have the dimensions of the picture and the frame all together. Okay? Now, I want you to look at the sentence in the book for number 48, because word problems, 99% of the time, the sentence structure is the equation. Okay? The sentence that gives us our equation is the second sentence. It says the area of the picture, and I'm gonna show that as A sub P, area of picture. I'm just designating that that's the specific area. What's the word after the area of the picture? No, is. In word problems, your verb is your equal sign. So the area is, which means equals, 1/3. How do you write 1/3?